Hello everyone, myself Ankur Patel, and today in this third session of projection of planes, we will continue our practice with problems of projection of planes. So let's start with the first problem today. This is our problem number 8 because up to session 2 of projection of plane we have discussed a total 7 problems. So we will start with the 8th problem today. A square plate of size 60 mm is held on a corner on the horizontal plane. Plate is inclined to the horizontal plane such that the plan of it is a rhombus with a diagonal of 30 mm. Determine the angle it makes with the horizontal plane. The other diagonal is inclined at 45 degrees to the vertical plane. Draw the projections. So first of all, draw XY reference line. Now, right now the plane is resting on the horizontal plane. So to derive the first stage, we have to assume the surface of the square plate parallel to the horizontal plane, and we have to take one of the corner on the left hand side of the drawing. So right now we have assumed the square plate parallel to the horizontal plane. We will get the true shape of the square plate in the plan. So let's start with the drawing the square in the horizontal plane. For that we have to follow this particular procedure. So first of all, draw a line parallel to the XY reference line over here. Now from this point, draw a line inclined at an angle of 45 degrees to this line, having line is equal to 60 mm. Let us say that this is our point B and C. Now from point B, draw a line inclined at an angle of 45 degrees, having line equal to 60 mm. Here we will get point A. Now point A, again draw a line inclined at an angle of 45 degrees to this baseline and having line equal to 60 mm. We will get D over here and connect D to C. We will get the square resting on corner on the horizontal plane. Right now we can also say that all the edge of the all the sides of the square plate is equally inclined to the vertical plane, and that angle is 45 degree. If you want to draw the elevation of the square plate, project all these points vertically upwards. So this will be our A dash, this will be our B dash, D dash, this will be our C dash. Connect these points, we will get the elevation. And elevation is a line because right now we have assumed a plane parallel to the horizontal plane and perpendicular to the vertical plane. Now let's move on to second stage. So now in the second stage, as the plane is resting on the horizontal plane, in the second stage we have to derive the condition with the horizontal plane. But right now here in this question, the angle of inclination of the plane with the horizontal plane is not given, but it is indirectly given that plate is inclined to the horizontal plane such that the plan of it is a rhombus with diagonal of 30 mm. So now we have to draw a plan which is a rhombus with one of the diagonal measuring 30 mm. So first of all, project these points, draw the locus of D, AC and B. One diagonal of a rhombus will be 30 mm, which is A1, C1, and the other diagonal will remain same as BD, which is given in this top view of the true shape. So this will be our B1, D1. And now connect these points, we will get the rhombus measuring one of the diagonal, which is diagonal AC, 30 mm, and the length of the other diagonal will remain same that we have in the true shape. Now project this point upwards, we will get A over here, A dash, and now measure A dash to C dash on the rounder, take center at A dash and give an arc. Here we will get C dash, connect A dash to C dash, and now project these points BD upwards. Here we will get B dash, A dash, and this will be the angle of inclination of the surface of the square plate with the horizontal plane that we have to measure. So measure this angle by using the protractor and find the answer. Now we have to derive the third stage, and in the third stage we have to derive the condition with the vertical plane. So let us see what is the condition with the vertical plane given. So the other diagonal is inclined at 45 degrees to the vertical plane. Other diagonal. So what will be the other diagonal? For that we have to read the statement again, or statement of the problem again. Let's see. A square plate of side 60 mm is held on a corner on the HP. Plate is inclined to HP such that the plan of it is a rhombus with a diagonal of 30 mm. That means one of the diagonals measure 30 mm. Determine the angle it makes with the horizontal plane, and the other diagonal. That means the length of one diagonal is 30 mm, which is A1 C1, and the other diagonal will be B1 D1. So now we have to incline this B1 D1 at an angle of 45 degree. Now let us consider the case for the third stage, in which we have to find out the beta angle, because we are always going to redraw this figure over here, and this is a plan of the plane, and the angle of the plan is beta. And right now we have to find out the angle of B1 D1, because here it is given that the other diagonal, not the plan of the other diagonal. So this is the plan of the diagonal BD, and this is the true length of the diagonal BD, and we have given the angle of BD. So right now this given angle is phi angle, it is not beta angle. So how can we find out the beta angle? Now if we observe this figure, that the true length of the diagonal BD and plan of the diagonal BD will remain same. That means beta and phi will remain same. So now you can copy this figure by taking B1 D1 at an angle of 45 degree to the XY reference line. So draw a line inclined at an angle of 45 degree, and on this line mark B1 D1 first. So mark B1 D1. This is B1 D1, measuring it from the top view in the second stage. Now from the midpoint of the B1 D1, draw a line perpendicular to the B1 D1 and mark A1 C1 using this lens, measuring this lens, mark A1 C1. Connect these points, will be a rhombus or top view of the rhombus in the third stage, which is inclined at angle of 45 degree, or we can say that the diagonal B1 D1 of the rhombus is inclined at angle of 45 degree in the third stage. Now we have to draw the elevation in the third stage. For that, draw the locus of A, B, C, D from the elevation. So this is the locus of C, locus of B and D, and this will be locus of A. Now project these points A, B, C, D upwards. So here we will get A1 dash, here we will get B1 dash, here we will get C1 dash, and here we will get D1 dash. Connect these points A1 dash, B1 dash, C1 dash, D1 dash, and again D1 dash to A1 dash. We will get the final front view. Right now the front view is a parallelogram, and this is our apparent shape. Now let's move to next example. Example number 9. A rhombus is having its diagonal 100 mm and 50 mm long. Draw the projection of the rhombus when the longer diagonal is inclined at 30 degree to HB and 30 degree to VP. So here the inclination of the longer diagonal with HB and VP both are given. So the example or the problem we are going to solve in 3 stages. Now one important thing is, here the resting condition or the surface inclination of the rhombus is not given. That means the plane is resting on HP or resting on VP is not given, and any statement doesn't derive the rhombus is resting on HP or on VP. So we will assume the rhombus resting on the horizontal plane. So let's start. First of all, draw XY reference line, and after drawing the XY reference line, now we have to draw the rhombus by taking longer diagonal parallel to the XY reference line and on the horizontal plane. First of all, draw a longer diagonal having line 100 mm, diagonal AC. Now shorter diagonal of the rhombus 50 mm, so draw shorter diagonal BD. Connect these points A, B, C, D. We will get the rhombus having a longer diagonal 100 mm, shorter diagonal 50 mm, and the diagonals of the rhombus are the perpendicular bisector of each other. Now we have to draw the elevation. For elevation, project all the points. So here we will get A dash, here we will get B dash, D dash, and here we will get C dash. Connect these points, we will get the elevation. And right now the elevation is a line, because in the first stage we have assumed that the surface of the rhombus parallel to the horizontal plane and perpendicular to the vertical plane. And if any plane is perpendicular to the vertical plane, the elevation of that plane will be a line. Now let's move on to next stage, and in the next stage we have to derive the condition with the horizontal plane. So here the condition with the horizontal plane is given. The longer diagonal is inclined at 30 degree to the horizontal plane. Longer diagonal means diagonal AC makes an angle of 30 degree to the horizontal plane. So now we have to incline A dash C dash, which shows the length of the diagonal incline at an angle of 30 degree to XY reference line by taking A dash on the XY reference line. So draw a line, incline at an angle of 30 degree, and on this line, here we will mark A dash. Now measure A dash to C dash, mark this point. Over here we will get C dash, connect A dash C dash, and now measure A dash to B dash D dash, mark this point. Here we will get B dash D dash. So we have to incline this line at an angle of 30 degree by taking A dash on the XY reference line, because the elevation of the rhombus will represent the length of the longer diagonal. Now we have to draw the plan, and for drawing the plan, first of all we have to project these points A dash, B dash, D dash, and E dash. Now project these points. Here we will get T1, here we will get P1, here we will get A1, and here we will get C1. Now connect these points, we will get the plan of the rhombus. So this will be the plan of the rhombus, and we can say that AC is the true length of the diagonal of the rhombus or longer diagonal of the rhombus, and A1 C1 is the plan length of the longer diagonal of the rhombus. Now let us derive the third stage, and in the third stage we have to derive the condition with the vertical plane. So what is given? So here it is given that the longer diagonal is inclined at 30 degree to HP and 30 degree to VP. So with the vertical plane, the longer diagonal makes an angle of 30 degree. The longer diagonal makes an angle of 30 degree to VP. Longer diagonal, that means the true length of the longer diagonal makes an angle of 30 degree to VP. Not the plan of the longer diagonal makes an angle of 30 degree to VP. And as you know that we have to copy this figure always over here. So first of all, draw an inclined line. Incline at 30 degree to the XY reference line, and on this line mark AC. So mark AC on this line, which is our true length of the longer diagonal. And if you want to copy this figure over here, that is the plan, we have to find out the beta angle for the plan of the longer diagonal AC. So the plan of the longer diagonal is AC. So first of all, draw a locus from C, and now measure A1 C1. Put your rounder on A, give an arc on the locus of C. Here we will get C1. This point will be our A1. So this will be our A1 C1, and which is the plan of the longer diagonal, and this will be our angle beta. So this is our A1 C1. Now copy this figure on this A1 C1 or the plan of the diagonal A1 C1 over here. For that, find the midpoint of the diagonal A1 C1 and draw a line perpendicular to line A1 C1 from this point. So we will get B1 D1. Connect these points. We will get the top view of the rhombus, in which the plan of the diagonal makes an angle of beta to the XY reference line that we have find. Now we have to draw the elevation, and to draw the elevation, first of all draw the locus of these points C, BD, and this will be our locus of A. Project these points. Here we will get A1 dash, here we will get B1 dash, here we will get C1 dash, here we will get D1 dash, and connect these points A1 B1, B1 C1, C1 D1, and D1 A1. We will get the final elevation or front view, which is our apparent shape. Now let's move on to next example. A hexagonal plate, a 30 mm side, is resting on one of its side on H. The side on which it rests makes an angle of 45 degree to VP, and the plate makes an angle of 30 degree to the horizontal plane. Draw its projection. So first of all, draw XY reference line. Now the hexagonal plane is resting on the horizontal plane, and it is resting on one of its side. So first of all, to derive the first stage, we have to assume the surface of the hexagonal plane parallel to the horizontal plane and perpendicular to the vertical plane. So we will get the true shape in the horizontal plane or true shape in the plan in the first stage, and we have to draw the true shape by taking one of the side of the hexagon perpendicular to the XY reference line and on the left hand side. So let's starting with the hexagon. So draw a hexagon having side 30 mm by taking one of the side on the left hand side. It should be perpendicular to the XY reference line. This is our A, B, C, D, E and F. Now we have to draw the elevation. For that, project all these points vertically upwards. So this will be our elevation, A dash B dash, C dash F dash and D dash E dash. Now in the second stage we have to derive the condition with the horizontal plane, because the plane is resting on HP and the condition with the horizontal plane is given here. The plate makes an angle of 30 degree with the HP, or we can also say that the surface of the plate makes an angle of 30 degree to the horizontal plane. So now we have to incline this line, that is we have to incline this elevation A dash B dash to D dash E dash at an angle of 30 degree to the XY reference line by taking A dash B dash on the XY reference line. So draw a line, incline it at 30 degree by taking A dash B dash on the XY reference line. This will be our D dash D dash. Now measure C dash F dash from A dash B dash, take center at A dash D dash, A dash B dash, and give an arc over here. Here we will get C dash F dash. Now we have to draw the plan in the second stage. For that, project these points vertically downwards. This is the projector of AB, projector of CF, and projector of DE. And now draw the locus of A, B, C, D, E, F parallel to the XY reference line on the right hand side. So these are the locus of A, B, C, D, E. So here we will get A1, here we will get B1, C1, D1, E1, and F1. Connect these points, we will get the plan of the hexagonal plate. So this is our plan. Now we have to derive the third stage, and in the third stage we will derive the condition with the vertical plane. So what is the given condition with the vertical plane? The side on which it rests makes an angle of 45 degree to VP. The side on which it rests. On which side the hexagon plane is resting? Yes, it is resting on side AB on the horizontal plane, because right now the elevation of side AB is on the XY reference line. So the side AB will remain on the HP. So we have to incline AB at an angle of 45 degree to the XY reference line. But as you know that we are always drawing this top view over here, or we are always inclining this top view over here. So we have to find out the beta angle for the plan of side AB, that is A1 B1. So for A1 B1 we have to find out the angle beta. And right now you can see that the true length of side AB and the plan length of side AB are same. So we can say that the 45 degree angle is the phi angle and beta angle. So now draw a line, incline at an angle of 45 degree, and now we have to incline A1 B1 at an angle of 45 degree to the XY reference line, because this angle is beta angle also. And if we incline F1 C1, and the angle of A1 B1, F1 C1, and E1 D1 will remain same, because all these lines are parallel to each other. So if the angle of A1 B1 is 45 degree, F1 C1 will remain 45 degree, and E1 D1 will remains 45 degree in the third stage. So copy this figure over here by taking F1 C1 on this line. So this is our top view, this is our A1, B1, C1, D1, E1, and F1. So right now the angle of F1 C1 is 45 degree, and AB and CD is parallel to the FC. That why the angle of A1 B1 and C1 D1 will also remains 45 degree. So our condition is satisfied. The side on which it rests makes an angle of 45 degree to VP. So side AB makes an angle of 45 degree to the XY reference line. Now we have to draw the elevation, and to draw the elevation, now we have to take the project draw the locus from these points. This is a locus of DE, this is a locus of CF, and this will be locus of AB. Now project these points vertically upwards. So here we will get A1, here we will get B1 dash, here we will get C1 dash, here we will get D1 dash, here we will get E1 dash, and here we will get F1 dash. Now connect these points, A1 dash, B1 dash, C1 dash, D1 dash, E1 dash, F1 dash, and A1 dash. We will get the final front view of the hexagon, and it is our apparent shape. So this is it for today. We are ending this chapter over here, and I prefer you to watch my all sessions of projection of planes if you want to understand projection of planes properly. So thank you for watching me today. We will come with some more topics in our next lecture. Till then, take care.